Hi, I'm Briggs, Tsugami Product Manager. Today, I'll explain synchronization control functions and how to utilize them in a Tsugami Swiss type lathe. Let's get started. Okay, so talking about synchronization control and the difference between synchronization control and composite control. I did another video on composite control explaining how that works and the difference between composite control and synchronization. Now I'm going to do this one for how synchronization works and how it's different from composite. So with synchronization control, okay, you have NC1 and NC2, sometimes NC3, and we will get into that in a different video. But for now, we're going to simplify it with just the two-path control. Okay, so this is XYZ1 and XYZ2. Okay, so let's say I wanted to turn a very long part. Well, eventually that long part is going to start to want to whip, like a piece of spaghetti, for very layman's terms here. It wants to whip, so you need to support that while you turn the rest of the length. And one of the big benefits of a Swiss machine is the guide bushing and the fact that your cutting surface is always very close to the guide bushing here. This is usually about 1 to 2 millimeters away. So you can turn an extremely long part and you always have support up here. But the problem is, where's the support out here once you start turning long enough, if the part is small enough? So at that point, what we want to do is come over with the sub spindle, clamp on the part, and then if we want to continue turning, we need Z1 and Z2 to be synchronized. We want Z2 to follow because they're both holding on to the spindle at the same time. So what would happen here is we would feed our Z-axis to a certain distance. We'll call it 10.0. We fed out 10 inches, now we need to start supporting. We're going to feed our sub spindle onto the part. Let's just call this M221. This is Z1, Z2, sync. Okay, so we're going to feed our sub spindle on. Z, we'll give it 0.5, it's just a random number. We're going to feed on to 0.5. We're going to clamp with an M20, and now we're going to also hit M221. So when this and this both hit at the same time, then this is going to sit on the cancel, M220. So this is just cancel, and that's going to be a weight code. It's going to act just like a weight code. All of my code here, all of my Z moves, any Z move after this is all going to be Z1, Z2 synchronized. This will follow relative to wherever this goes. So with composite control, I would be giving control of Z2 to NC1 if I wanted to use composite control. I wouldn't be synchronizing. Z1 would be sitting still at that point. So with synchronization, both axes are moving, but Z2 is actually mirroring Z1. So this would be the one in control over here, all the Z moves, and then you're going to cancel with M220. As soon as these both reach M220, then this will take control by itself again. It'll be independent to Z1, and they both will go their separate ways. So synchronization is both axes moving together simultaneously. Composite control is going to be giving an axis from one path to another path and giving control, but it eliminates the axis. So if I get composite, no more Z1, I'm controlling Z2 from over here. So that'd be the difference between synchronization and composite control and how you would utilize synchronization in a Tsugami machine.